Hi everyone, this is Stu Jones, Senior Organic Search Strategist at Click Consult. And for today's vlog, we're going to be talking about how we can apply multivariate regression specifically to factors which we think contribute to your organic search rankings. So as a bit of a caveat, I'm not in any way a data scientist. I'm properly a beginner at this. So if I have misinterpreted anything within this vlog, please do leave a comment and we can all kind of learn together. Why is this useful? Why are we doing this? Well, Google tells us that there are over 200 ranking factors. We've seen people like Brian Dean create these blogs that try to predict what those 200 ranking factors are, but the truth of it is nobody can really know. So we really just have to play with the data that we have at hand and that we know to some degree affects the output of Google's search engine ranking pages and where you sit for certain keywords. The first thing you need to do is grab your data set. And for that, I've used ranking data for an anonymous client. It's a very small sample data set. We're only using or looking at about 17 keywords here. But for each of those 17 keywords, we've pulled the top 50 ranking positions per keyword. In this data set, I've omitted the URLs in order to keep this client anonymous. But for every one of those URLs, I've used the Mozscape API using a Python script that I pulled and modified from the Moz website to pull all external links to that URL. If anyone is interested in how that's done, I'll leave a link below this video and you can take a look at the Python script that they have as an example on there. And then if you want any more information, please leave a comment in the blogs and I can either talk you through how to do that in the comments, or we could potentially leave that for another vlog for another day. So for the other two columns, these are using complete arbitrary made-up data, and we're testing what we've called page quality score and page speed. So page speed, in reality, we could potentially use the Google PageSpeed API to pull that data, because obviously it's going to be inefficient to go through every single URL and pull that using the PageSpeed Insights tool. It's not something that I've played with, but I have played with the other Google APIs quite a lot, and they're not too difficult to get working. So maybe that's, again, a project for another day. Page quality score would be something that would be really fantastic to have access to for our competitors' URLs via AdWords for certain keywords, but unfortunately we don't, and there is no Google API that's capable of pulling that data. That was kind of a misthought on my part. I should have used a different metric, but for the purposes of today, it still helps us to explain this example. But in the future, you could replace this column with literally anything that you could think of that can be pulled for both all your URLs and all your competitors' URLs. So now we're looking at our dataset in Microsoft Excel. One thing you need to keep in mind here is all your variables that are going to be, factors contributing toward the dependent variable need to be inline. So for example, external links, page quality score, and page speed all need to be together next to each other as columns. Once you've got that, you need to check that you have an add-on. And the best way to do that is by going into File and then into Options. And then under Options, you'll have Addons. And you want to check that you have an active application called Analysis Tool Pack. If you don't have that, go down to the bottom of that window and under Excel Add-ins, click Go, and then tick the radio for Analysis Tool Pack and click OK. And you can check that you then have that under the Data tab at the top of Microsoft Excel, and it will be in the final column that says Analysis. So that's your setup for starting your regression analysis. And in order to do that, you can click on Data Analysis, and it will open this new window. You need to select Regression. And you'll get this new window where you'll have input that you need to enter yourself. So the Y range will always be the dependent variable. The Y range is always the variable that you're trying to predict based on the other factors. Click into the Y range option and then click into the title, which in this case is position, and then do Control Shift and down to select everything in there. A word of caution, don't just select all of column B, because that tends to give the add-in a bit of a headache, so it's best to avoid that. And then for the X range, again, go to the top title, select the other two titles, and then Control-Shift down to select everything in there. You need to ensure that the labels option is ticked, and that ideally you want to put this to a new worksheet. Once you have all those options, click OK, and the data analysis add-on will give you this information. If you've not done statistical analysis in the past, this might look a bit scary. We're not going to talk about everything here today, but I am going to tell you the parts that you kind of need to know. Now, I've kind of already done this and highlighted the areas that we need to learn about, so we'll do that now. Okay, so the first cell that I've highlighted in this yellow color is adjusted R-square. Again, you can go away and research this and research the small details around what these statistics mean, but adjusted R-square is a way of understanding how good your model is at indicating the dependent variable based on all the other variables that are affecting it. So in this case, we've got a really, really great score because we've got 0.996%, which means that this data model is a really good model for indicating our position. Significance F we're going to leave for now. The other information you need to know about is highlighted in these yellow cells in column B, 18, 19, and 20. And these are the coefficients. So these are the correlation scores for how much of an impact each of these factors has on our dependent variable. And in this case, if you think about the relationship that we're trying to predict here, it's really a kind of inverse correlation because more links is equal to a lower ranking position. If it were a normal correlation where more links equaled more of something else, then we would expect these values to be non-minus values. But in this case, they are minus values, and that's a good thing because it's exactly what we're trying to predict. You'll see here, if you're not familiar, quite a strange number. This is mathematical notation or scientific notation, and all it means is this number, so 1.49942 times by 10 to the power of minus 6. That's just being expressed as a scientific notation. These are our coefficient scores. And then the only other one I wanted to mention is the t-stat value. Now, t-stat shows for page quality score as the lowest value, which indicates that it's the most significant independent variable. I'll show you in a minute, but when we change that independent variable, it has the biggest consequence on our position than if we were to change the other two variables. Why is that? Well, this is just arbitrary sample data. I'm sure that if we used real-world data, all these t-stats would probably be a lot closer together. That's great, we've got that data, but how can we actually use it? Well, we need to then ask ourselves a question. What would we expect the ranking position be if we had, say, 20 external links, a page quality score of 60, and a page speed of about 75? Well, we can do that with this equation here that I've highlighted in cell B25. So here, y is equal to our intercept value, which is 92.0304, plus our external links coefficient value of 1.499 times by the number of external links that we are asking in our question, plus the page quality score coefficient value times by the page quality score in our example question. And finally, we add the page speed coefficient value times the page speed score that we have in our final question. If we click into this cell, we can see that under a sum, the outcome of that is 31.74. Based on our model, again, it's a very small model and it's not using real-world data, but based on this model, if we had 20 external links pointing to a page with a page quality score of 60 and a page speed of 75, we would expect for that page an average rank of 31.74. And as I mentioned before with this t-stat, if we change, for example, the external links, if we make that 30 instead, we're not bringing that value down very much at all. If we change the page speed to 90, again, we're barely bringing that value down. But if we change the page quality score, which has the largest t-stat value, or in this case, the smallest, if we change that page quality score to 80, we can see it's come down. So our average rank for a page which had 30 external links, a page quality score of 80, and a page speed of 90 would actually now be around about position 11. And that's really how we can use regression analysis for predicting, or at least trying to utilize the data that we have for predicting ranking positions organically. I hope this is really useful, and it's by no means exhaustive. There is massive amounts of content on the web for understanding regression analysis, and I encourage you to go and read about that. For now, thank you very much.